Second to the last video, test for goodness of fit, which is 11.1. Hopefully you've already downloaded this worksheet. So we're going to do two examples. They're going to be totally different than what we've done, similar in our steps. Oops. Miss Davis is FaceTiming me because she does this every day. I know you want to see her, but I'm not doing it right now. Anyway. All right, so let's talk about what this is. So the chi-square test, we've done the chi-squared. Remember, it's that funky looking X with a squared at top. It can be used to test a single variance, which we've done in the past. But it's also a test if a frequency distribution fits a pattern. So if you are doing a project on which sport do you like better, which I hope you're not doing a project on that. I hope you actually have some kind of smart thinking behind your project. But let's say, which sport do you like better? Basketball, baseball, football, okay? That you could use a chi-square test to see if the populations, to see if the frequency distribution fits some kind of pattern, okay? Now, just so you know, it is always a right tail test. It's always a right tail test. We've known that from before, which means it skews it down to the right. Here are the steps. They're going to be a little different, but not too different, that we're going to take to do the hypothesis test for this. And this is what you'll show in your project if you're doing one like this. Step number one, obviously, state your null and alternate hypothesis. Now, here's where it's going to be different. Watch what I do on my examples. Because your null and alternate hypothesis, it's not going to be like, oh, chi-squared equals chi-squared. It's totally different. So please watch and observe my examples to use for your project. Step number two, state a significance level. Again, that's going to be up to you when you do it on your project. Most of the examples I'll give you, they have the significance level stated. Step number three, you have to compute a chi-squared statistic. So the chi-squared statistic is the sum of your O minus E squared divided by E. What is the O minus E? The O is your observed frequency. E stands for your expected frequency. And then divided by E. Now, there's this thing called degrees of freedom. There's a reason why I want you to write this there. We're going to use this in when we do our calculator part. The degrees of freedom is equal to the number of categories minus 1. Meaning if you chose the 3 sports, baseball, basketball, football, you would do degrees of freedom would be 3 minus 1 or 2. Okay? So step number 3, you'll have to compute this test statistic, and that's what we'll use as our p-value. Then we reject or do not reject. And then you summarize your results, just like we've done before in the past. Okay? So let's do this first example, and hopefully this will help you when you do your test, your project. Okay, so here's what will happen. At the 5% significance level, test the claim that there is no preference in the selection of fruit soda flavors for the data. Okay, so we got cherry, strawberry, orange, lime, grape. We observed 32 like cherry. We expected 20. We observed 28. We expected 20. So just to kind of go through this, there are 5 categories. We expect there to be 20 in each of those. So that means there was a total of how many people that we tested? 100. Okay, so 100 divided by 20 would, 100 divided by 5 would give us 20. That's what we expect in each. So if I had 3 categories and I did it with 100 people, I would probably think that there'd be 33, 33, 33, or 33, 33, 34. Okay, so that's how you would figure out this expected value. We'll talk more about that in the next problem. All right, so here are our null and alternate hypothesis. These are going to be different. Our null hypothesis is that, yeah, there is no preference. in fruit soda flavors. But my alternate would be there is a preference. In the fruit soda flavors. Now, this is not going to tell you which one, although it might look like, oh, everybody likes cherry more. No, all it's going to say is that all it's telling you is there is some kind of preference between these categories, okay? Step number 2, the significance level was 5%, so our alpha is 0.05. Step number 3. Okay, here we go. The chi-squared step. And I'm going to write down my formula, which is the sum of my O minus E squared divided by E. Actually, that should be the sum on the entire thing, not just the top, just so you know. All right, what does this mean? So you have to do the observed minus the expected squared divided by the expected for each one, and then add them. That's what sum is, okay? You have to do this. And actually, I got to erase that because it's really bothering me. It's for the whole thing. So let me show you what I mean, okay? So we'll start with good old cherry, okay? Cherry is, we observed 32 minus, we expected there to be 20. Square that, divide by 20. Add that to, we observed 28 people chose strawberry. We expected there to be 20. Divide by 20 squared. Plus orange, 16 minus 20 squared divided by 20. Plus 14 minus 20 squared divided by 20. Is this making sense? And then one more, 10 minus 20 squared divided by 20. Notice, when you square these, you're not going to have any negatives. Okay? Now, be really careful when you punch this into your calculator. So I'll just do the first one here. But you would just do 32 minus 20, square it, then divide that by 20. 7.2. And I'm going to give you these numbers. Now, I posted a video on how to, if you want to actually put this into the calculator. I think it's a little complicated. You're not going to have more than 5 categories, so you might as well just figure out the decimals. But adding all these up, you get 18. Okay, this is an important number. Circle that. That 18 is an important number. From here, once you get that number, you're going to want to write this down. Okay, you are going to go to your new best friend on the calculator, I should say, on calc. You're going to go to second vars. So let me show you. Second vars. And go down to where it says chi-squared CDF, which is number 8. Chi-squared CDF. Now, it's going to be 3 numbers you have to type in. A lower number, an upper number, degrees of freedom. The lower number is always what you got here. So 18. Your upper number, since it's right-tailed, 9. Your degrees of freedom, remember, degrees of freedom, number of categories minus 1. Since we had 5 categories, minus 1, that would make 4. Hit enter. 0.001. 0.001. That is your p-value. 0.001. So, do we reject or not reject? Well, that is less than 0.05. So, if that p is low, reject the HO. Reject the HO. What does that mean? If I'm rejecting, there is no preference. then I am supporting the fact that there is a preference. And that makes sense. Look at those numbers, 32 out of 20, 20. Yeah, they prefer something. Those are crazy high. There is enough evidence to support the claim. That there is a preference in soda flavors. Okay, and again, you can't say which one they prefer. You can just say there's enough evidence to say, yeah, people definitely have a preference in soda flavors. Okay. All right, we're going to do one more. So next page, and then we'll be done. And then you can do your problems here. All right. A researcher surveyed 100 randomly selected teachers in a large school district and found that 46 wanted to extend the school year, 42 did not, and 12, they had no opinion. At the 0.05 level of significance, is the distribution different from the national distribution where 45% wished to extend the school year, 47 did not want to, and 8 had no opinion? Okay, so we're going to actually have to do a frequency chart, an observation chart on this. So here's what I mean. Let's draw this. We've got, looks like 3 categories, right? Teachers who want to extend the school year, teachers who don't want to extend, and teachers who had no opinion. Okay? This was our observed, this was our expected. So researcher found 100 randomly selected teachers in large school district, found that 46 wanted to extend the school year. So 46 wanted to extend the school year. 42 did not. And 12 had no opinion. So that's what we observed. But what do we expect it to be? Now, if you just had these 3 categories without these percentages that they gave you, you would just do 100 divided by 3, and you'd put 33.3, 33.3, 33.3. But because they gave you these percents, and they're going to do this on homework tonight, you have to do a little bit of extra math. Not too hard, though. 45% wish to extend the school year in the national around the world. So if I sampled 100, then I would expect 45% or 0.45 of 100 people to wanted. I would have expected there to be 45 people. 45% of 100 is 45. In my group, 47 don't want to extend the year. So out of my 100, I would have thought 47 would have chosen not to extend, since that's what the national average is. Those who had no opinion, 8%. So I would have thought 0.08 of 100, or 8 people. These are my expected values. Very different from the last one we had because we were given these percents. Okay, so if they give you these percents, you have to multiply it by the amount of people you surveyed, 100, or if this was 200 times 200, okay? All right, so now that we have that, let's set up our hypothesis test. So again, this is going to be worded a little differently. Number 1, our HO. You don't want to say, oh, there's no preference to it or whatever. You actually say the following. Your population would be that everybody would be around 45% for having extending school year, 47, et cetera. So you would say those who want to extend school is 45%, not extend 47%, and no opinion. I spelled that wrong. Opinion, 8%. Okay? That would be the null hypothesis. The alternate would be, no. My distribution that I get in my sample would not be the same as the national. The distribution is not the same as the national level. Okay, so that's what you would do first. Number 2, state your significance level. We got this. Alpha is 0.05. All right, number 3, chi-square the sum of O minus E squared over E. Okay, so we need to do 46 minus 45 squared over 45. Add that to 42 minus 47 squared, divide 47. 12 minus 8, add that to squared, divide by 8. Okay? Calculate these, and I got about 2.5541. I kind of went a little crazy there and added extra decimals, but because the more decimals you add, the more accurate you are. Now you're going to go in your calculator and go to chi-squared CDF. That's found in second VARS. Second VARS. Chi-squared CDF. Remember, this is now your lower number, 2.5541. 2.5541. 99999 is your upper. Your degrees of freedom, I have 3 categories. I take away 1, so that would be 2. So 2. Sorry, I'm trying to move it over so you can see it without the reflection there. And I get a p-value of 0.28. It's pretty high. A 0.2, we'll say 79, which is much greater than 0.05. So what does that mean? That means you do not reject the HO. That means there's not enough evidence to say the distribution is not the same as the national level. Bummer. All right, hopefully you understood that. If you didn't, please go back, really understand this part right here, okay? If you're doing your own project, you probably won't have these percentages, so you probably would just do 100 people divided by however many categories you have. But if you have any questions, let me know. Bye-bye.